It is possible to perform arithmetic operations between matrices, but only if certain conditions are met. So, two matrices can be added or subtracted if they have the same dimension. When we add or subtract the matrices, we are adding or subtracting the corresponding entries. To multiply a matrix by a number or a scalar, we multiply every element of the matrix by that number. Here are some examples. So let's say we have a matrix that is 2 by 2 and adding another 2 by 2. When we add these together, it's going to be A plus E to get this entry here, B plus F to get this entry here, C plus G to get this entry, and D plus H to get this entry. To add or subtract two matrices, they have to be the exact kind of matrix that the other is. They have to be the exact same. So 2 by 2, 3 by 3, 3 by 2, 4 by 5, whatever. They have to be the exact same. If they're not the same, you cannot add them together. If we're multiplying a matrix by a scalar, S, when we take S and multiply it by this matrix, it's just going to be S times A for the first entry, S times B for the second, S times C for the third, and S times D for the last. And there are some properties for addition and scalar multiplication. So we're going to say that A, B, and C are n by n matrices, meaning that A, B, and C are all the exact same kind of matrix, and that S and T are some scalar multiple, some number you're going to multiply the matrix by. So matrix addition is commutative, so A plus B is the same as B plus A. Matrix addition is also associative, so A plus B then plus C is the same as B plus C and then add A. Scalar multiplication is associative, so S times TA is the same as S times T times A. And then scalar multiplication is distributive. Two scalars adding together multiplied by a matrix A is just S times A plus T times A. Or some scalar S times two matrices that are adding together is just S times A and S times B. So then you can add those together. For matrix multiplication, you have to be extremely careful. This is very important. You can only multiply matrices if their dimensions are correct. And what do I mean by correct? Well, if A is a matrix and it's n by n, and B is a matrix that's n by k, then their product C will be an n by k matrix. You have to make sure when you're multiplying to check the dimensions. And when I say check the dimensions, you have to make sure that the inner numbers are the same. See how the n and the n here are the same. They have to be the exact same number. This just means that when you multiply, you need to have the middle number, in this case the green n, between the two matrices equal. So n and n here. So when you do matrix multiplication, you will get a new matrix that is m by k, because these two, for lack of a better phrase, cancel out. So here's an example of how matrix multiplication works. It's a little bit cumbersome, so you gotta be patient. So if we have a 2 by 2 matrix and another 2 by 2 matrix multiplying each other, this is how the results will be. It's going to be A times E, and then B times G, and then you'll add those together for the first entry. Then it'll be A times F plus B times H for the second entry, C times E plus D times G for the third entry, and then C times F plus D times H for the last entry. And once you work all that out to get the multiplication and addition, you will get another 2 by 2 matrix, or whatever matrix you'll have. In this case, this is a 2 by 2 example. Now, there are properties of matrix multiplication. We can say that A, B, and C are matrices for which the following products are defined. There is an associative property of matrix multiplication where A times B times C is the same as A times B then times C. There is also a distributive property of matrix multiplication, where A times the quantity B plus C is equal to A times B plus A times C, and then the quantity B plus C times A is equal to B times A plus C times A. You must be careful that matrix multiplication is not commutative. So A times B and B times A will not produce the exact same results. So be careful. Matrix multiplication is not commutative. It is associative, there is distributive property, but it is not commutative.